Hello everyone, I am Sumani. Now I am going to present you the topic of combinations and permutations with constant repetitions. So before getting into the topic, let us know what is a combination, permutations, and how a repetitions works on combinations and permutation. And at the end, we conclude the topic with combinations and permutations with constant repetitions. So now let us know what is a permutation is. A permutation means it is an arrangement of objects in a specified order. So there are n number of objects present. So we need to arrange those objects in an order. So in a simple words, we can tell that selection and arrangement combinedly called a permutation. That means a sum of selection and arrangement is called a permutation. So for better understanding, let us look into an example. So a student has 10 books, but only room for 6 of them on a shelf. So there are only 10 books, so we need to arrange 6 books on a shelf in such a way that how many ways of arrangements of these books are possible, we need to find out. So how many ways we can arrange those 6 books on a shelf? So this is the problem. So first step is we need to pick 6 books from those 10 books. So this is called selection, and later we need to arrange these 6 books in on a shelf. So that means we are arranging those 6 books. So here in the picture we can identify that. So 10c6, and we are for selection. Now we are arranging those 6 books. So for that, the formula or answer is 10p6. In 10p6 ways, we can arrange 10 books. We can arrange 6 books from the 10 books on a shelf. So I hope you all understood this example. Now permutations without repetitions. So here is a image where we can derive this formula: n factorial by n minus r factorial. We use this formula for number of r permutations of n objects without repetitions. So now we can represent npr in this format also: p of n comma r, p of n comma r, and the formula is n for n factorial by n minus r factorial. So simple example, how do we write 10p4? That is 10 factorial by 10 minus 4 factorial, that is 6 factorial, and the answer is 5040. So the result or another formula for number of linear permutations of n objects without repetition is, that means here there are n objects, and we know how many ways we can arrange these n objects, means n factorial ways. So this is the formula for permutations without repetitions. And next, let us understand with better example to get better understanding. So how many ways 10 people can be arranged in a row? Here they didn't mention any constant. They didn't mention any condition that only 6 places are there or 4 places are there. They didn't mention. So we can arrange 10 people in 10 factorial ways. And in that first bit, a bit, so that certain pair always be together. So first step to solve this problem is we need to consider two members as one unit, and remaining 8 members, consider them individually as one unit. So combinedly 1 unit plus 8 units equal to 9 units. So all these 9 units can be arranged in a line is 9 factorial ways, as we discussed in the before formula. For each of these arrangements, so there is a 1 unit, right? So in that 1 unit there are 2 people. How many ways we can arrange these 2 people? Means we can arrange in 2 factorial ways. So now the total arrangement is equal to 9 factorial into 2 factorial. So this is the answer or solution the for certain pair always be together, and now certain pair never be together. This is another problem. So this is vice versa for the above problem, right? Converse for the above problem. So we total arrangements of those 10 10 people minus certain pair always be together. So this is a formula so that we can get certain pair never be together. That is 10 factorial minus 9 factorial into 2 factorial. 9 factorial into 2 factorial, we got that from the above problem. And total also there are 10 factorial arrangements. And I hope you all understood permutations without repetition concept. Now, permutation with repetition. So, as the name suggests, we are repeating the objects. So, here is an image. First, this is a first image. So, in first image, objects are arranged linearly. In the first box, there are n choices. There are n choices to place in that first box. And similarly, we are repeating the objects, right? So in second place also we are having n choices. Similarly with all other places in that linear arrangement. So the formula is n power r. So the formula is n power r. So here is an formula based problem. So find number of possible outcomes when 10 coins are tossed. So all these coins are destined. So for each coin we have head or a tail, right? Similarly for 10 coins we have head and tail. So the solution for this 2 power 10, that equal to 1028. Okay, I hope you all are clear with the topic of permutations without repetition and with repetition. Now, let us get into the topic of combinations. Yes, combination means selection of items from a group of items. Just picking the items is what a combination is. But the constraint is we should not consider the order of a selection. We can select in any way. There is no restriction that we need to select in this manner only. There is no such conditions are applicable on this combination. And the formulas are and formulas is for deriving this formula. Generally, what is a permutation? As I mentioned, it is a selection and arrangement process. Both combinedly is called permutation, right? So npr, this npr equal to selecting all objects and arranging that or objects in r places. So npr equal to ncr into r factorial. R objects in r places means r factorial. So from that we are getting this ncr formula. Ncr equal to npr by r factorial. So what is an npr? As I mentioned before, n factorial by n minus r factorial into r factorial. So this is the formula for ncr. Next, so here are few more conditions or formulas. nc1 equal to n, ncn 1, nc0 1, and ncr can also be written as ncn minus r. For that there is a short formula, 10c3 equal to 10c7. So these are the formulas in combinations. Now for better understanding, what so generally everyone has a doubt that when permutation is applicable, when combination is applicable. There is a dilemma in these two concepts, right? So clearing that topic, I'm going to explain you the question. That is, 10 friends meet in a party and shake hands with one another. Number of shake hands are, so if there are two persons, if both person are shaking their hands, that means A is shaking to B. Similarly, that is equivalent to B is shaking to A, right? Similarly with all the 10 friends, so number of shake hands equal to 10 number of two combinations of 10 people. That's it, 10c2. So both are equivalent, right? So that's why we are choosing combinations in this problem. If both are distinct, like if one is not equivalent to another, that means um, if a boy is distributing a chocolates, then the boy is giving chocolate is different from another boy is giving chocolate to him on his birthday. So this, in this example, we can take permutation, but in this example we took combination as a prior. Okay, so this problems gives the difference between permutation and combination. I hope you all understood. And next, combination with repetition. So here is a wonderful formula that that makes the problem very simpler. So number of r combination of n objects with repetition. This formula is very mandatory for the repetition problems in combination. So n minus 1 plus r c n minus 1, where number of ways of replacing are similar balls. So this formula is applicable to these questions also. What are those questions? Number of ways of placing are similar balls. If there are red balls, for five red balls in six boxes, we need to place them. So in that cases we use this formula, n minus 1 plus r c of n minus 1. So for the next one also, number of binary string of length n minus 1 plus r with exactly n minus 1 ones and r zeros. So in this case also we are using the above formula. So now here is a question: number of ways of placing n similar balls into four distinct boxes. See, here is an image. There are four boxes placed here, and there are how many boxes? There are n equal to 4. There are four boxes, that means n equal to 4. And here is the formula, because we are using here n similar, that means here we must consider 10 similar balls. Here 10, not n, it is 10. And n minus 1 plus rcr, this is a formula because we are considering similar balls. That means combination with repetition, I said we need to use this formula. And what is n? Number of boxes, that is 4. What is 10 r? 10 similar balls we are placing. On solving this we get 10 13c10, that is equal to 13c3. So I hope you all understood this problem. And next, the last topic, the main topic of this video is permutations with constrained repetition. What does the word constraint means? That means the limitations. It is referred to arrangement of elements where some elements are repeated at certain number. So what is constant repetition mean? So before that, a permutation, in permutation each element is unique, and when permutations with repetitions, there are certain elements that may appear more than one or many times it can, but for a constant repetition there will be a arrangement of elements where some of the elements are repeated at certain number of times. So for that formula is, so number of permutations of n objects, there are n objects placed, and in that q1 elements are same, q2 elements are same, and so on, qt elements are same. So sum of all these q1, q2, q3 and so on up to qt, that equal to number of objects we have taken. So for that the formula is n factorial by q1 into q1 factorial into q2 factorial into and so on qt factorial. This is a generalized formula. So now let us look into the question so that we can understand better. So find the number of arrangement of the letters in the word Mississippi. MISSISSIPPI. just PPI. So total number of letters in Mississippi is, here there is no L, just here no L, Mississippi. So total number of words that are, total number of letters, sorry, total number of letters in Mississippi is 11. So total 11 factorial by, now how many are repeated, how many types we have to see. So in this, yes is repeated for 4 times, so 4 factorial. Mm, and s is also repeated for 4 times, so 4 factorial. P is repeated for 2 factorial, and other elements, other uh, are repeated only once. What is that other? M is repeated for 1. So in this way we find the number of arrangement of letter in this such type of words where certain particular element is repeated certain number of times. So total number of objects factorial by repeated factorial into another element repetition number factorial. So in that first bit is in which 4 eyes. So there are 4 eyes in Mississippi, right? So those 4 eyes are together. So that is when this term together comes, we need to consider it as one unit. And remaining 11 minus 4, 7. Remaining 7 units are considered individually. That equal to 8 units. So number of arrangement in which 4 eyes are together means, see, first generally total. How many units are there? 8 units are there. So that are arranged in 8 factorial ways. And in that, there are 4 yes repeated, s are repeated 4 times. So 4 factorial. And p is repeated 2 times. So 2 factorial and 1 factorial for m. And there is 4 eyes that is considered as 1 unit. That is 1 factorial. And remaining one, this 1 into 1, where is into 1, this why we kept, that is the doubt, right? So that is the reason we kept for 4 eyes arranged in one way. So all these 4 eyes, I, I letter are arranged in one way. So that is into 1. So in this way we conclude this problem. And another question, there is a word called rearrange. So number of arrangement of letter in the word rearrange. So simple. So there are 9 letters in rearrange, right? Where R is repeated for 3 times, A is repeated for 2 times, E is repeated for 2 times, and N and G are repeated for 1 time. So the total arrangements is 9 factorial, means total number of letters in the word 9 factorial into 3 factorial, 2 factorial, 2 factorial, and 1 factorial into 1 factorial. So this is the total number of arrangement of letters in the word rearrange. Now in that sub question is such that no two R's are together. So there are 3 R's, as I mentioned before, there are 3 R's, right? So here the question is such that no two R's are together. First step to solve this problem, the first step is we need to arrange the remaining elements. So what are the remaining elements? E, A, and G, E. These are the remaining elements. How do we arrange? Similarly, see, there are 6 letters, so 6 factorial. Which letter is repeated how many times? So A is repeated for 2 times. E is repeated for 2 times. And N and G are repeated for 1 time and 1 time. So here is the formula. Arranging these letters is equal to 6 factorial by 2 factorial into 2 factorial into 1 factorial into 1 factorial. So next step is, so consider one such arrangement. So consider this is the only one arrangement. So in that, how many places are there to arrange these 3 R's? So there are 7 gaps, right? 1, 2, 3, and 4, 5, 6, 7. There are 7 gaps. So we need to arrange those. That means we need to select gaps. So we need to select gaps to place 3 R's. So no two R's are together. So 6 factorial by 2 factorial and 2 factorial. So how many ways did we arranged? 7CR. So this is a total number of arrangement such that no two R's are together. I hope you all understood this problem. Thank you all.